And we'll start at the highest level. Again, these are the dashboards, and I'll take you into a live demo of what we've actually built. And I'll show you how we're managing and how we're alerting and how we're drawing the collaboration. So this is a live dashboard, and immediately you can see the 7 risk factors across the top, and immediately your attention is drawn to economics. And this is really an index, and it's saying that we're performing 260% worse than where we should be. Keep in mind that we should not get too excited. This is all mock data for this purpose of this presentation. So let's look at economics, and we'll click on here and we'll drive it to economics. And we'll actually see the various regions in the province that are causing the problem economics area. And here we see Central Ontario is the issue. So we'll then look at all the stations in Central Ontario, and we're able to identify which stations are actually driving the bad economics. And from this particular example, you see that Pickering is at the top of the list, but Alliston is a close second, and it's trending even worse. Now, we may want to do this, we may want to look at this for each risk factor, but we also may want to do this at an asset view, so looking at asset-centric dashboards. And again, here you see that economics is the problem area, and performance is trending 50% worse. But immediately you're able to see that breakers is the cause, the root cause of the performance index being red. And when you click on the breakers, you'll see that the worst breaker happens to be, let's ignore this one for now, air blast circuit breakers. It's actually performing 230% worse. And actually, we have an investment plan to eliminate all air blast circuit breakers on the system. So we can do that with each one of the risk factors. So we have 7 of them, and you're able to identify quickly the target areas that require our attention, and from here we would drive to more detailed reports. And as an example, from a breaker perspective, we're able to see near real time the situation on our associated with our breakers. So here we have low voltage breakers, SF6, the number of outages to the year 2010, and if we want to look at 230 kV SF6 or GIS breakers and oil breakers, then we're able to see which ones require our attention, and I'm going to click on air blast here, and hopefully, and what you see is basically it's the worst performing breaker on the system, and we're doing something about it. So the other key element of all of these wonderful dashboards is actually being able to collaborate with the field. So the dashboards that I show you, they would be readily available to our superintendents, and the superintendents in the field, our service provider, would then look at the stations and take the necessary appropriate action and have that conversation with asset management that basically have a discussion as to why the asset should be red or whether or not it should actually be green because some action has taken place previously. This is another way of viewing all of that information I just presented. So we are enabling a spatial view. So what I've done here is for performance, I selected 2009, 2010, and I'm able to paint the entire province with the performance associated with our assets. I'm going to click on this little red dot here, and what you'll see is that it's Perry Sound. It gives the long and lac, the performance index, indicating it's performing 2.5 times worse than where it needs to be. And I'm going to look and see, well, what's driving that performance. And this is near real time. So as information is entered, this system is being updated on a regular basis, on a daily basis for that matter. And what we see here is that there's a transformer, and that it's had 2 outages in the past 2 years, and that's what's causing the root cause associated with the red. If we want to see more details associated with Perry Sound, we go and bring back a detailed assessment of the entire station where we see all of the assets at that station, the inventories, the ages, how much money we're spending on preventative maintenance, what we should be spending on preventative maintenance, the corrective work orders, and whether or not the ratio is out of whack, And immediately you can see in these two red areas where the corrective maintenance is worse than preventative, and basically that would require us to take some action. And you can see again in performance that the benchmark is performing 2.5 times worse, and it's basically saying that the transformers are the root cause of that problem. So the outage frequency is 0.6, and the benchmark is actually 0.2 outages per year.
Bruno,
so this is drawing our attention. It's shining the light on assets that require our attention. It's helping us to build that business case that is defensible before our regulator. Another key aspect of what we're trying to do is to build the relationships between the elusive risk factors. So what I'm talking about there is actually building the correlation, say, between performance and dollars spent. So what we have here is we're collecting all of our information on all of our assets, and you see that transformers, we spend the most money. And when I asked this question of our own staff, what they thought we would be spending the next amount, what is the next highest, people often say breakers. But you see that the big aha for us was that we're spending a lot of money on site and infrastructure. That's the grass cutting and the copper theft and doing all of the grounds maintenance. So we're spending a lot of money, and a lot of the money appears to be corrective maintenance. So the yellow is corrective maintenance, the green is preventative maintenance, and again, what we're trying to do is target the ratio of corrective to preventative that is normal with the rest of the industry. So based on this graphic alone, if we were to focus in on our top 5 assets, we would actually account for close to 80% of the dollars that we spent.
Bruno, Jesse, may I
yes.
Have a couple questions from listeners wanting to know how you know the condition of these assets. Are they equipped with sensors, or you have PMU or other instrumentation installed to inform the dashboard? Is there real-time SCADA information flowing in?
So actually, there's a number of factors that are driving condition, all of which you mentioned. So some of them are online monitoring of transformers. We do the typical standard dissolved gas analysis on transformers. All of the standard tests that would drive condition, that would drive health, are those algorithms we're using and will be using in fully developing this dashboard. So we're using all of the industry standards, IEEE, as well as the asset condition health algorithms to derive condition.
Thanks.
So economics, so we saw how we're spending our money at the various stations, and now I'm going to show you where we're spending most of our money. And again, here is a real live graphic basically showing that which stations we spent the money at, and you can see that the #1 station happens to be Clairville. But the big aha for us was that we're spending money at this particular station, and it's not a station at all. It's our central maintenance service center. So we're spending a lot of money on actually repairing and fixing equipment that goes back to our central maintenance service shop. And all of it appears to be categorized as corrective. So what we've done with this is we were actually taking action to have our service center, our CMS shop, actually code the work orders differently so that we get a better picture. And if you look again at some of the key stations where you see some anomalies, this station there's a lot of corrective work, and at this station there's a lot of corrective work. And again, we would want to ask, why is there so much corrective work going on at that station, and can we turn that into preventative maintenance? So the analytics are shining the light. They're giving us the information at our fingertips, and then we're taking action as a result of it. And the last slide that I have, again, one of the elusive correlations that the industry struggles with is how do we spend our money with aging assets. So what we've built is an algorithm to look at how we spend our money as an asset ages over time. So this happens to be a graphic for breakers, and what you see is there's a lot of money spent initially, so there's a lot of teething problems with our breakers, and then it undergoes some midlife crisis where we spend a lot of money, and it seems to get us to the end of their life. And these models are going to help us in terms of being able to predict how much money we're going to need in the future to be able to sustain our assets. And we're hoping to be able to crack the elusive, I guess, correlation between all the risk factors, so i.e. performance and condition, performance in dollars or economics, and condition and performance as well.
Thank you, Bruno. Just one more quick question. A listener asked if you're using software developed on SAP or a special software module or software that you wrote yourself to handle this.
Yeah, so we're leveraging our business intelligence, business warehouse, so we're developing the algorithms ourselves. We do not believe that there's any commercially off-the-shelf algorithms to be able to do this kind of analysis.
Thank you.
The last slide was the roadmap. We're hoping to be able to do this over the next 2 years and it is a journey. We've just started this program last year, and we hope to have all of our assets prioritized and assessed by the end of 2012.